Hey students, this is lesson 211, lines and angles. In this lesson you're going to learn how to identify parallel lines by their equations and also how to tell if points are collinear. You may not even know what that word means, but we'll get to that soon enough. I'd like to start by going to the second page. Actually go to the third page. Right here, develop and understand A. And number 3 says, without graphing, decide which of the equations represent parallel lines and explain. Okay, so in number 3, we're going to try and decide which of these are parallel. And just thinking about that, one of these equations isn't even linear. So if it's not linear, it's tough to be parallel, and that's this one here, because that does not fit this form because of this squared term there. So we'll eliminate that one. And then, so if you're looking at the other ones here, now think about what the coefficient m does. That is the rate of change. It's the slope. And so if it has the same rate of change or slope, it should be parallel, as long as it's not exactly the same line. And we'll just take a quick look at that. So here I have that equation, those two equations first, and notice that the equal sign is highlighted here. So when I graph them, I'm only going to be graphing those two. So I'm going to graph them. And there they are. And indeed, they're parallel, and that's because they go up at the same rate. They both go up 2 for every one they go over. See that here. Now let me add those other equations, and you can see that those aren't parallel. This 2x. Hit enter there. Graph that one. There's that one. That one is the nonlinear equation, and the 5x plus 3. And you should know that since that one has a slope of 5, it's going to be steeper than the other two. So I'll graph that one also. There, that one went through. So the two that are parallel are these two, y equals 2x minus 7 and y equals 2x plus 3. All right, so explain. And the way we're going to explain is because they have the same coefficient and they're linear. Okay. All right. Next one I want to do is this problem right below it here. It says consider the line y equals 5x plus 4. A second line is parallel to this. What do you know about the equation of the second line? Well, we know that if it's parallel, it'll have the same coefficient. So we know the coefficient of the second line is 5, since this one has an equation of 5 and this one's parallel. Now it says write an equation for a line parallel to y equals 5x plus 4 that passes through the origin. If it passes through the origin, we know that it goes through the point 0, 0. And since the input is 0 here, the output is the y-intercept, or the constant term in the equation. So this equation is going to be y equals 5x plus 0, which, since we're adding 0 there, we can just write it as 5x. It's a direct variation equation. C says write the equation of a line parallel to y equals 5x plus 4 that crosses the y-axis at the point 0, 3. Well, the output when the input is 0 is the constant term. So, and we know since it's parallel again that the coefficient will be 5. So we're going to write 5x plus, and the constant term is the output when the input is 0, which is given to us in this point. So we're going to say it's 5x plus 3. And D says write an equation for the line parallel to 5x plus 4 that passes through the point 2, 11. Hint, the data pair 2, 11 must satisfy the equation. Again, let's start with y equals 5x because we know it's parallel. And we know we have to add something to that, a constant term. And we know that that constant term must make it satisfy this data pair 2, 11. So when y is 11, I'll just substitute 11 for y. And x is 2, so I'll substitute 2 for x. And when I add the constant term, it has to be true. Well, 5 times 2 is 10, and 10 plus 1 is 11. So my equation is y equals 5x plus 1 goes through the point to 11. All right. Turn the page here. And number 5 says, a line has equation y equals 3x minus 1. Find the equation for the line parallel to it, passing through the point 3, 4. I'm going to ask that you do that. Try this one tonight. Do it just like we did the last one. So this is for you to do and to share with your group tomorrow. All right. And I'm going to skip down to number 3, the vocabulary. All right, this is an important word. It said points all lie on the same line. So, so they are all in a row, so to speak. And the word for that is collinear. And if you look closely, you'll notice the word line in this. Maybe that'll help you remember it. But L-I-N-E, collinear means points all on the same line. So which points on the graph are collinear? You can think about that. But you might notice that A, B, and C all line up. So they are considered collinear. Now think about this also. One way you can tell if they're collinear, let's say we didn't have a graph. Notice that the rise over the run there is 2 and 3. Rise over run here is 2 and 3. And if I take the rise over run from point C to A, I get 4, up 4 over 6, and 4 over 6, of course, is also equal to 2/3. So collinear points, if you find the slope between those points, you will always get the same number. So we're going to do number 7 here. It says, without graphing, find a way to determine whether the 3 points below are collinear. Explain your method. And our method is for us to find the slope between the points. And if the slope is the same, then the lines have to be lining up. So find the slope. If they line up, the slope between them will be the same. Okay, so we got to check out the slope. So let's call this point A and this point B and this point C. And so first thing we'll do is find the slope from A to B. And of course I'm going to use my slope formula here since I'm given points. So I'm going to subtract my y values, which is the 26 and 5. And then I'm going to subtract my x values on the bottom. And I'm going to get 21 over 7, divide that, I get 3. And now I'm going to go from B to C. And in that one, I'm going to take my y values, 26 and 20, subtract those. My x values, 10 and 8. And 26 minus 20 is 6. 10 minus 8 is 2. 6 divided by 2 is 3. This should be enough information to tell that they're collinear. But if we want to just make sure that we realize that, we could go from A to C also and make sure those are. But just think about that. If the slope is the same from A to B and from B to C, we know that the points are going to line up. But we'll do from A to C also. So we're going to do 20 minus 5. So I'm doing this and that. And then I'm going to do 8 minus 3. And that's 15 divided by 5, which is 3. And that is the same. So we're gonna say yes, they are collinear. Okay. The other problem I'm going to ask you to do for tomorrow is number 8 and have that ready for class. All right, that's it. I'll see you in class.